This is Mark. I'm going to cover segment 3 of the ETS Practice Exam. For this case, I'm going to cover problems 17 through 22. I believe we're jumping now into solving problems using data sets or graphical illustrations. For this case, it's showing the graphical illustration of the corporate support for the arts by sector in 1988 and 1991. So we're moving from left to right, so 1988's in white. And these are just the proportions for each of the given sectors. So there's 6 sectors right here. And the total proportion for a given year adds up to 100. So basically these are just subsets of the total revenue, which is given right here and here. And so for the first problem, it states the 2 corporate sectors that, here's the key word, increase their support for the arts from 1988 to 1991 made a total contribution in 1991 of about how many $1 million. So what we need to do here is find out which sectors increase their support. So it has to be trending upward. So notice like right here, it's trending from left to right upward. But then right here, it's trending downward and downward, downward. So we're only going to care about financial, insurance, real estate, and services for this case. And it says it's focusing on 1991's revenue. So we're focusing on anything in the dark shades, so these 2. So if we're considering, if we let like R1 equals a 630 mil, this is revenue 1, and revenue 2 equals a 520 mil. So this is what we're focusing on. And we can let like P1 is the first proportion for finances, it's going to be 0.26, and P2 is proportion for services is 0.22 as a decimal point. So basically what we're doing is we're finding the total proportion, so the total revenue, so we're taking the total proportion to find the total revenue in 1991, so we're going to use this revenue, is going to be equal to R2 in revenue 19 times P1 plus P2. Or this is just going to be 520 million and times the total proportion. So that's 0.26 plus 0.22. And see, this comes out to 520 times 0.48. So it's approximately 50% almost of 520 million. And then from here, we can just multiply. You could take 52 and 48. The reason I did this is another way, if you need to multiply very quick and you have a zeros place, I'm not considering this zero place right now, and I'm not considering the decimal. I'm going to show you why later. So essentially, or the reason is because if I multiply by 520, essentially any number, you're just adding a 0 at the end anyways. So right here, this is simplifying the process. So you take 8 times 2 is 16, carry the 1, 8 times 5 is 40, plus 1 is 41, carry the 0, 4 times 2 is 8, and then 5 times 4 is 20. So this is 6, 9, just add them up for 2. And then if we were to add a 0, I'm just taking that 0 and I'm placing it right here. And if I were to add a decimal, notice how the decimal notation starts right here. And because it started for a whole number here and I shifted 2 units to the left, so I'm shifting 2 units to the left, what I end up doing is I'm going to do the same right here. So basically this comes out to be 249.6 mil. And it says in the question, round your answer to the nearest $10 million. So we're going to focus on the tenths place, 49.6, and that's just going to be approximately the 250 mil. It's going to be our answer. And right here, it's already in millions, so we just put 250. And then you shade in 250. Okay, there's that problem. And then right here it says, how many of the 6 corporate sectors listed each contributed more than 60 million in both 1988 and 1991. So that's key information. So right here, what we want to do is we're focusing on 1991, so dark shade, and we need to find that which sectors contributed more than 60 million. So what we want to do right here is we're focusing on revenue, 520 mil. And we need to find, basically, the key is to find the fractional ratio. So what we do in this case, you take 520 x1. This is basically we're considering, I believe we're focusing on 1988 and 1991. So basically, so we're focusing and 630 mil. So we're focusing on these two cases. So we're going to start with 520 mil. We're going to represent, and then this is going to be set equal to 60. So we need to find the fractional ratio of, which is going to be basically x1 is going to be the fractional ratio that of the part, which is 60, over the whole, which is 520. So essentially, if we divide both sides by 520 of x1 is 60 over 520. And then this is just the part divided by the whole. So this gives us our lower bound. And essentially, this is equivalent to, we notice it's going to be greater than, this is going to be greater than 10%. It's actually going to be around 0.1 if you calculate it. And that's 11.5%, approximately. And then we do the same for the other case. So we take 630 x2 equals 60. And then we have x2 now is this 60 divided by 630. It's going to be a little bit less than 10%. It's going to be approximately 0.95 or approximately 9.5%. So therefore, the sector, we need this sector in, let's say, 1988, which focuses 630, must be greater than, so that's this case, must be greater than 9.5%. And we know the sector in 1991 must be greater than 11.5%. Because the question stated we need to find for both 1988 and 1991, this condition needs to be satisfied. So we're focusing on these two conditions. And if both of them are satisfied, then the sector satisfies the condition. And so for the first case, we notice in 1988 we're going left to right. This is 5% is less than 9.5% right here. So this is false. This is less. And then we notice 17 and 22 are greater than both of them, so that's check. 31 and 20 is greater, satisfies. But now 8%, and this is 1991, it's not greater than 11.5%, so that fails. 6% is not greater. And then both of these percentages are greater, so that equals to, so now we have total of 3 checks out of 6. So the answer is going to be 3. And then for this one, it says, from 1988 to 1991, which corporate sector decreased its support by the greatest dollar amount? Okay, so this is a critical problem. Let's go here. For this one, we need to find any sector that's decreasing, so trending downward. So we're not going to focus on these services, or we're going to focus on these 4 because they're decreasing. But we notice that wholesale only has a 2% decrease, and then other only has a 2%, but whereas retail has 11% change, which is 8 to 19 is 11, and then manufacturing also has a 11%. So they're both equivalent in that case, but for this case, let's suppose we take 1% of 630. We know this is equal to 6.3. All I did was I took the decimal and I'm moving over. This is like 10%. This is or 1%. And then 100% 630, and we take 1% of 520 equals 5.2. So if we add this to now that if we're taking, now if we take, let's say we take 2% now of 630. Well, this is just 2 times 1% of 630. And this equals to 2 times 6.3, which equals 12.6. So if we draw on a number line, we take the difference between each of these two. Let's say we start with 5.2, and we're going towards 12.6. Every time I add another, like 3%, like for instance, I'm adding another 6.3. But if I add a percentage right here, I'm only adding 5.2. So notice how the difference between 6.3 and 5.2 is greater than 1. Or it's greater than, of course, it's also, yeah, it's greater than 1, but it's also greater than 0. And basically, this is like 1.3. So every time this increases by a percent, you know, the 630 increases by 1%, it's separating by 1.3, a distance 1.3. So therefore, the larger percentage right here is going to have a much larger difference, essentially. It's going to have larger separation distance. And therefore, but even though they're same distance of 11%. So what to solve this, actually, what you end up doing is you're going to take the upper bound, which is 0.31, and this is for 1988. So we know manufacturing is going to be, just because the separation distance, we know using this logic is going to be larger. But if you want to solve it using math, just solve it using algebra. You take the upper bound times the revenue, and you're subtracting 20% of 520, and you find that difference, and then you get 0.19 times 630, and then you take 0.08 times 520, and you find this is case 1, this is case 2, and we find that case 1 is approximately like 92 mil, and case 2 is approximately 78 mil. Of course, case 1's greater than 2, so this is 1's greater than 2, so it was a larger difference. Basically, it's a and that's what the question, it says which. So right here it says which decrease it supports by the greatest dollar amount, and of course 92 is greater, so this would be manufacturing. Now here it says of the retail sector's 1991 contribution to the arts, so we're focusing on retail. 1/4 went to the symphony, and 1/2 of the remainder went to public TV. So we're focusing first on the retail. So we need to focus on retail right here. And it says 1991, so we're focusing on 8%. So basically we're focusing on retail, and a contribution to revenue equals 8%. So that's critical. So basically we know this in this problem. It says the contribution to the arts went, so we separate symphony equals 1/4. But then because the retail is 8%, we're taking this contribution essentially, basically if we have, let's just suppose we have a set. This is 100%. Retail is somewhere in here, like let's say this is smaller, it's 8%. But 1/4 of this is like symphony contribution. And basically this is a proportion now of that, so we're taking now 1/4 of the 8%. 1/4 of the 8% is equal to this, and we have TV equals 1/2 of the remainder. Now, if we found remainder, we know the remainder, let's say remainder. We know the remainder plus 1/4 has to equal 1. It's 100% of the contribution. Of the total contribution, basically, to the arts, so we're separating 1/4 of this went to the symphonies, and then within the retail, half of the remainder went to the public television. So basically the remainder of everything is going to be, because 100% has to make up the contribution in this retail, which is actually of the 8%. It's just 100% of the 8%. And then now that we know this is like, we could just represent as R. This, we basically subtract 1/4 from both sides. So R equals 1 minus 1/4, or 4/4 minus 1/4, which is 3/4. So now for TV, we know that the remainder is 3/4, but we're taking 1/2 of the remainder. So 1/2 remainder is 1/2 R, is 1/2 times 3/4. 1/2 of the remainder equals 3/8. So now the contribution to the television we know is now 3/8. So this is 3/8 times 0.08. So, and we know this is 1991. So we know the revenue in 1991 was 520, because revenue 2 is 520 mil. So basically the answer now is going to be, we're going to take the 520 mil, we're going to multiply the difference between these two components. We know the symphony made larger, 3/8 is larger than 1/4. And we're basically, how many more $1 million did the retail contribute to TV? So the TV proportion is going to be larger right here. And we're taking times 0.08. We're multiplying 3/8 minus the 1/4. So all we did is we're taking 520 times the TV component minus 520 times the television, or times the symphony. So we start with 520 times the TV proportion. So 520 times TV proportion minus 520 times symphony proportion. And this equals to 520 times 0.03 minus 0.02. And this gives us about 5.2. So there's that one. It's going to be A. So that's that for that problem. Okay, so 21, it says the total number of recording titles distributed by music distributors L and M is 9,300. The number of recording titles distributed by L is 7,100, and the recording titles distributed by M is 5,200. Which of the following must be true? So it could be any of these choices, but the key here is we're going to introduce sets. So if we represent like one set by L, and then we know they intersect because they each contribute amount, and we represent this by M. What we know here is the total addition. So basically we know that what we need to find is like what is in here essentially. We know the total number of elements, so recording titles distributed by music L and M. So like we know that L contributed certain amounts. Everywhere within this whole set we know is 7,100, and we know M has a certain number of contributions. So these are elements, and then you add up the sum. We know that's 5,200. But the key here is we need to find whatever goes in here. We can represent the intersection as like X in the middle. And what we need to find now is, what we know is this right here. If we take this section right here, we know that this is 7100 minus x, so forth. And we know that the total in this whole, all these sets, is 9200. So we also know, if we're taking this component, right, the shaded region's 5200 minus x. Okay. So now what if now we're going to add x at the end. So we know that 7100 minus x, and then plus, this is equivalent for both sides. This is now, we're doing plus x plus the center plus 5200 minus x, and we set this equal to 9300. So basically, now we have minus 2x, so this is going to be imply we have 7100 plus 5200 minus 2x plus x is minus x equals 9300. So if we bring x to one side, and we, now we're going to have 7100 plus 5200 is 12,300 minus x equals 9300. So we bring x to this side, and then we bring 9300 to this side. So we're going to take 12,300 minus 9300. So this positive becomes a negative, this negative becomes a positive, becomes x. So we have 3000 equals x. So this is our representative contribution for both of them at the same time. So basically, 3000 of the recording titles are basically contributed by both of them, or they have an overlap. So basically, L contributed to that, but also M contributed as well. And then the total number of elements everywhere of the total set is going to be 9300. So basically, the first one says more than half of the titles distributed by L. So what is 1/2 times L? 1/2 times equals 1/2 times 7100 is that's 3550. And then B says more than 1/2 titles distributed by M, so we have 1/2 M. That's 2600. Okay. So for A, it says more than 1/2 of the titles distributed by L are also distributed by M. Okay. Well, this is, we know, less than x. So that's the key information right here. And what we need to find is that it has to be, this is not less than x, this is greater than x. And what we need to find is it has to satisfy less than x, because this says more than half of the titles distributed by L, which is right here. We're also distributed by M, which is not the case. So because this is 3000, so this is 3550, so we're representing plus 550. These were not distributed by M. Only 3000 were distributed by both, so that doesn't follow. Now this is less than x, so for B it says more than half of the titles distributed by M, which is 2600, are also distributed by M. Well, yes, because within this set, 2,600 of the titles distributed by M are within the set of 3,000. It could be any of those elements. And of course, there's 300 remaining to get to this point, so therefore more than half of the titles are also distributed by L. If you increase this to 27, that satisfies more than half, but it still satisfies they're also distributed by L. So therefore B, A doesn't follow just because there's that remainder that I was mentioning, and it's greater than X. And then of course C is wrong because it says no titles. Well, we know there's that intersection. So the answer choice, most logical choice, is going to be B. Now for 22, this one could be a little bit tricky, but it says if C and D are positive integers and M is the greatest common factor of C and D, then M must be the greatest common factor of C in which of the following integers. So greatest common factor, anytime you have a multiple, let's say we do 24, you know, we know that this is 8 times 3, but we can break this into 2 to the 3 power by 3. And then we could take, like, let's say we take 16. Well, it's 8 times 2. That's 2 to the 3 times 2. So the greatest common factor here is, of course, it's going to be 2 to the 3. As we simplify, it's the greatest factor that is synonymous between each of them. So basically, we got to take the highest degree, and basically a greatest common, any number that you take, it doesn't matter. Like if you take, you could take a number 2 to the cube times 3 times 5 times 17 and then terminate here. What you notice is these are the prime factorizations. Anytime you break down a simplified number, you break down into prime factors. And essentially, if you have, like, let's say 2 times 3 here times 5 times 11, well, we know that the greatest common factor is going to be 2 times 3 times 5. They both share, and that's the maximum limit. Because this has a cubed, and this number right here does not. You just find the greatest factor, which happens to be 30. So this is 30 times 11. Well, this is 30 times 4 times 17. And because 4 is not a factor in here, it doesn't satisfy that relation. So that's where greatest common. So like with this one, we're going to do like counter examples. For instance, if you start with, for instance, like D, if you take D squared. So if you take a number C, C equals like, could be M times alpha. And alpha is just like a set of all these factors right here. It could be any of these factors, but M happens to be the greatest common factor. This could be like a different factor. Beta is like, could be like 2 times 3 times 5, any combination. And basically they both have the same. And then if you take D squared, so D squared is this M squared times beta squared. Because there was no factor shared in beta, anytime you square these, like if I'd square this, 2 times 3 times 5, it's 2 squared times 3 squared times 5 squared. All I do is I square the same factorizations. Well, right here, okay, so essentially I have M squared beta squared, so it's not the best example right there. So right here's a good one. So if you take, like, let's say C, it's better to do counter examples like this, 4, and D equals 2. Best case is to try to simplify this as much as possible. So you start with C equals 4, D is 2, well, D squared equals 4, which equals C. So this is the greatest common factor right here is 2 times 2 and this is 2 times 1 is going to be, initially it's 2. So initially m equals 2. And then when you multiply by d squared, we now m equals 4 because now they're equal. They have the same factor. 4 is the greatest common factor. And now if we do 2d, well, it's the same thing. In this same case, we take 2d equals 2 times 2, which equals 4, which is c. So then we have m starts with 2, but then we take 2d, we now m equals 4. Okay, c times d. C times d is 8. So cd is 4 times 2 is 8, which is just 4. Yeah, we just take 4 times 2. So basically, well, the initial factor of c and d was 2. When we multiply by cd, you get 8, when now is a multiple of 4, which happens to be a factor of c, which means that m becomes 4. And then 2 plus d. Well, 2 plus d equals 2 plus 2 is 4. So again, m equals 2 initially, and you do 2 plus d's transform, and then m becomes again 4 because that's a factor of c. And they're both equivalent, so they have the same factor, and therefore m is the same. And so therefore it doesn't follow for E, D, C, or B, so your answer has to be A. And of course, like anytime you have a factor, like I did like 2 times 3 times 5 times 11, you could have, this could be like C, and D is like 2 times 3 times 5 times 17. So they have the same m as 2 times 3 times 5 is the m. But right here, when you add c plus d, it's just 2 times 3 times 5. We're adding 11. This is c plus 17. Notice that this is always going to be greater than any of these numbers. It's never going to, it's never going to fit into a factor. And basically, you're never going to be able to condense this into a multiple of any of these numbers. So you're not going to be able to condense eventually back into its prime factorizations right here. So it won't be able to increase the m, or the greatest common factor value. And that, but this was just shown like this. These problems you can use elimination as a way to solve it. And I believe I'm going to stop right there. Terminate right here for now, and then I'll continue for the next segment. I'm going to go hopefully another few, and I'll try to solve all 40 problems, and hope this helped.